Okay, thanks for this opportunity. Let me share a few of my understanding with respect to gear design. So basically, approach is about how to do the first time right designs. In India, even with our AI Summit also, more technology focused on AI with respect to IT related sectors, how much with respect to mechanical sector. This was my question to myself first. How we'll make first time right gears when we are doing a prototype? This is a success of every company rather than doing multiple iterations. This is a core focus, how to put design, manufacturing, quality all together and make the first time right product. So gears are backbone for every machinery. It may be industry, it may be automobile or a tool or whatever it may be. So the design, how to integrate the other disciplines while I'm doing the first design. Okay, so let's go with that. Very importantly, I could able to say one word. The paradigm shift is focusing on gear is a old era. Today, our focus is particularly with respect to integrate every element. It may be a bearing, shaft, or lubrication system, or related to vibration, or anything related to the functional performance of the system, how we will integrate. Huh? Hello? Hello? It's better. This is just I can't see. Hello? Right. So today, we have multiple softwares in the industry. You can take any kind of FEA software, gear calculation software, multi-body dynamics software, or system analytics, or even with calculation software, everything having its own mathematical calculation. If you know the system, means application, understanding about the product, performance requirement, any system will help up to certain percentage. It doesn't mean which car is better. Car is, if I have the driving capability, I can drive better than a higher size car also. Such a way, big companies, they can invest in R&D. Small companies, they can't do iterations or cannot retain engineering forces. That way, today, every company who are designing any gearbox, that's a very simple thing, torque density is very, very important. Means 1 kg weight of a gearbox, it may be a gear, bearing, whatever it is as a gearbox, how much torque I can transfer. So this is torque density inside built into the gearbox. Then when coming to the other applications, efficiency, today EV gearboxes, bus, every area, noise is the first important criteria. Everybody will do gearboxes, put into the assembly, doing a particular load condition, they will feel a noise is upcoming. It may be a whining noise, it may be a rocking noise, or it may be some kind of whining, different noises. Why it's coming, why it's not addressed during design, this is the major purpose. Then particularly, when coming to a product like aerospace components, reliability matters. Then when it comes to a windmill, durability matters. Because 1,50,000 hours, when we are designing a gearbox for a windmill, 3 megawatt or 6.3 megawatt, even today, if you have a chance to visit ZF Wind Power at Coimbatore, you can see they are having 13.2 megawatt test rig in-house, 2 fully halt tested gearboxes. So proto validation is such an important for their durability point of view. Coming to weight, yes, every flying element, it need low weight. All right. So temperature control. Any of the industry, I have my own client, other clients. The most of the issues with your renowned gearbox is temperature rise, oil seal leakage. So this is also cost to the companies. That's why we can have Romax, we can have Mazda, we can have Kissoft, we can have FEA, any kind of engineering software. When it is integrated with the right tools, it will get the best solution. I'm just putting a word with respect to one of my clients' application. It's a very simple, it's a Logia Corp Kanpur. You can see a simple worm gearbox put into the application, even any kind of standard brand. Name anything, I won't like to name 4 or 5 people. just to embrace them. It used to fail shaft, particularly one particular reason. So they are considering gearbox, torque capacity, overhanging load. Everything is okay. So what about the roller's inertia? There is nowhere consideration in any of the catalog. What is the starting torque? So I am having 12 kilowatt motor consumption, requirement are continuous, but I will put 25 kilowatt motor for without knowing the reason. That is inertia. So I'm having a roller, that's a payload, already loaded. It's like a conveyor also same. So this way, when it comes, the overhanging load coming to the shaft used to fail, or seal used to fail. Take one kind of another application of the same client. It's a shredder, means recycling machine. It cutting the knife kind of stuff. It will cut the material into pieces. Our sack, polythene sack kind of stuff. Again, it will go to a pallet. So there also the loading system. So here, taking a gearbox design as per ISO 6336 standard or doing as per some software calculation will not work. So here some kind of knowledge level of application, what I want to say here, very, very important. Coming to EV gearboxes. So this gearbox, when we started the client understanding on the NVH, it's one kind of benchmarked gearbox, reproduced, I can say other way, but it's not providing the expected results. What went wrong inside? What are the data captured inside while doing the re-engineering concept? So it's not like OD, ID, addendum, dedendum, module, phase with heat treatment material doesn't matter. It need a lot of understanding about dynamics and transmission error related characteristics. So that is very, very important. Take a windmill gearboxes, how they are predicting the loads. The load at Kayatadu, Kanyakumari, Satara, or go to Pune. It's a different loads for a same load. How they are predicting. So how they are using SIMPAC kind of softwares for load simulation. This is very, very important. Why I put AI related to here is doing manually all this calculation. It's boredom, and again people will not do this calculation. So certainly they need high advanced data programmed tools in the existing software. It may be an API program or it may be a coded program individually, but that will do an expert who had 30 years experience or PhD with multiple universities. Their knowledge is programmed and it is doing the redundant job. So that's why these AI programmed calculations helping a lot in these industries. Very simple. We know only 4 failure modes or 5 failure modes gears. It may be pitting, it may be a scuffing or surface durability, micro pitting, root stem. ISO 6336, if you take part 1 to all numbers, we can get all the theories. Will this same theory applicable to every application? If this theory will help me to write first time design, is a questionable. Again, how we are feeding the data. So here, a kind of expert knowledge programmed rightly in a software, AI kind of stuff, it will iterate and give you the best results rather than doing multiple calculations. So this I will explain later, all these things. Coming to design optimization, people will do gear design, going to the bearing, it will not work. Going to the shaft, it will not redesign. So there is a multiple loop. Today, any software in the industry, it is multi-body oriented analysis. They will not do only gear design alone. They will do shaft, bearing, lubrication system, thermal, everything together as a system rather than an individual part. So to integrate all these multi-physics into a design environment, it's very difficult for manual operation. AI programs only will help you. So today, many softwares, they integrated as a system. Try to use it, you will get it, the benefits. Coming to, I put multiple softwares used here. Very importantly, when it's an NVH related things, how we are controlling the transmission errors. This matters. So this transmission error due to gears, shaft deflection, housing distortions, or due to churning of oils, which contributes where? That is an expert level of iteration required, whereas the integration of multi-physics is very, very important. So we would like to concentrate. So this is one kind of system level approach. Particularly LTCA means loaded tooth contact analysis. So when I am applying a load, 10%, 30%, 50% or 80%, with respect to this load, how my system will behave, my gear, how it will deflect, my shaft, how bending will happen, my shaft, how torsional deflection will happen, how the bearing stiffness come into the picture, how my bearing supports stiffness to the grounded area, all matters. So that's why loads, then clearances with respect to the housing and stiffness, deformations of bearing, shafts, bearings, displacements. Particularly, I have the best design in my drawing, but how my people manufacturing, what kind of level of accuracy? I will have two tolerances always, either plus minus or plus plus, minus minus. Cumulatively, I will get an accumulated tolerance. Which tolerance favors me with respect to my performance? If my manufacturing quality team doesn't know about the required tolerance zone, where I have to place my shaft, if I am making 20 diameter, 0.1 to 0.2 or O1 to O2 tolerance, O1 favors me, O2 favors me. If I don't know that, he will do in middle by default. Let's assume housing concentricity error, axis parallelism between two shafts. These all come into the picture. What we call as a KH beta into the calculation. As a designer, we will ask, what is your KH beta into the calculation? How you are ensured this number after assembly considering all your production tolerances. This question answered by any manufacturing team rightly, I can say manufacturing is right. Else, there is a gap, we can expect surprises after assembly and testing. That's the reason, while designer makes any design, his responsibility to do the design for manufacturing, design for assembly, design for quality checking, and design for performance. It's not DFM alone or DFX alone. A complete end-to-end consideration is the important role of a R&D engineer. It's not only design logic. And here you can find so many parameters, either one, two, or multiple of these. It will produce the errors, and that will contribute to your NVH related characteristics. How you will rule out each and every one? Today, softwares available partly, AI algorithms available with very specific people. That is highly paid, highly sophisticated R&D team, but I believe it's very much not easily available to the outsiders or public forums, including research scholars or including high level, I can say, colleges or institutes also. So that's a big gap. If you go to our books, Maitra book, PSG design data book, if you refer that formula, go to any one of the reputed gear design, you can't match the parameter. Very specifically, I can clear cut. The reason is, today what we are studying with our engineering colleges, what industry following, big gaps. We raised this issue with multiple forums, even with the AGMA, and Raghuji also helped a lot to bring some Matt Corrosion's support on that. Thanks for that. Lot of awareness came after that. Many colleges called me, asked how to get AGMA standards and how to update. Then ISO, even for your kind information, being an BIS member of our, this PGD 33. So ultimately, we lost our control after IS 4460. If you refer the standard with old IS standard, you can't do any calculation with the software. So we did lot of exercise last 2 years and converted or otherwise migrated to ISO 6336. At least we can do our BIS calculations when QCO comes. Many industries suffered with QCO, OTRs, omnibus technical regulations like that. When in ministry puts some regulations, you will catched by that approval authority. So these issues, at least at gear area, somewhat we are progressed today. So, so it will be a long subject. Let's go ahead. So very important thing is predicting the root strength. It's not only design, module. How many people, honestly, in the manufacturing, checked your root portion after manufacturing, whether it is having a notch, undercut, how the fillet joins together, whether the root strength is uniform, the cutter, how it forms the layers, means layouts, and how the uniformity comes, whether it's a full round fillet or trachoidal fillet. See, 20% of your torque carrying capacity sits there. If I'm having 100 kilowatt today, doing a proper validation, I'm not talking about design. Design, everybody will say ISO 53.2, reference profile, A for cut finish gears, D for profile ground with PGB tools. Simple. That's all. Design people work over, they will put all in the drawing. Who checks in the manufacturing unit? How the root form comes. If this goes, I have seen a lot of RCA being a root cause analyzer. Many area, a known company, number 1, number 2 in India also suffered a lot of gear failure due to this issue. Very important is the gear profile, not only designed to be checked after manufacturing, validated for its surface stress on the root portion, very, very important. So here, the rolling, you can see the forces is not uniform from the, what we call DNF, or you can say your start of active profile to the end of active profile. The force will not be uniform. You can see the actual. We will split this from this portion to this portion where involute there. This point, let's take A, pitch point as C, in between B. So A, B, C, D, E. So that graph shows A, B, C, D, E, 5 points. How my load transfer from root to the tip of any gear, how much load sharing I am having with each tooth. If it is a helical, I will have the overlap contact ratio. How I am fixing the contact ratio. Am I really getting same contact ratio after manufacturing? So these matters very much. And shaft deflection also. So when one single shaft comes, by default our strength of material says there will be a bending. Then it also says there will be a twisting since torque transmitter. So bending, twisting, together my tooth portion will go a different twisting. I exaggerated. So bearing will also having a clearances. Again, shaft parallelism will be different. Housing, boring, concentricity will be different. All together, if you exaggerate, the bearings will go in one side. And if it is an intermediate gear, again critical with the 2 messes. The 1 pinion, 1 gear, how the load transforms, all together, if you see, the contact pattern will be very, very different rather than what we are predicting. So generally, if you not done anything, the contact pattern will go like this. If you use a blue match, you can't find in your factory because it's a zero loaded. No load spin test, it will give good contact pattern. But when it is loaded, how the contact pattern shift, I don't know how many prototype people are doing red die cam applying into the 3 tooth portion, 120 degree each, putting to the load. After some hours, are you opening the gearbox again, seeing how the contact pattern develops. This is very, very important to say how the loaded contact pattern shifts from the partial load to the full load. So exactly with a no load, you can get blue contact anywhere. When it is a 40%, it's supposed to be a egg kind of shape, not going either edge or tip. How it progresses uniformly, even with full load and overload also, it should not take stress concentration onto the edges. This is very, very important while you are designing a gear, such a way, multiple corrections. Every grinding machine you are seeing today here having multiple corrections, helix correction, crowning, variable crowning, twisting, even with micro gradient levels. Say grid level 9 by 16 or so many, what we can say, mesh kind of stuff, we can do the modifications. In spiral bevel, automobile lapping, a very, very different algorithm available. All not with a software with no load condition. It's supposed to be with your application loads, how you are deciding that contact pattern, how you are providing that micro geometry correction. This is very, very important rather than giving one number. Now coming to the major optimization area. So the stiffness of gear mesh. Let's take the pitch point here, A, B, C, D, E. It has to go smooth, means transmission error has to be at least a smooth curve, not one peak like this. If it is a peak, automatically it will create a NVH related issues. Again, temperature rise also. How temperature rise? A gear with X correction and a pinion with Y correction or X1, X2 corrections. This will create a rolling as well as sliding. Generally, if it is a rolling, a lubricant, there is no higher temperature rise. When sliding happens, default the flash temperature or what is ISO 6336 says part 4, it automatically rises to a peak, even 200 degrees centigrade if it is wrongly decided. That momentary peak will create a small scoring, pitting inside, even scuffing kind of related issues. So this we have to analyze. Then very, very important, last one is a transmission error. How my gears will perform as an integral part for a transmission error. Housing stiffness. How many people, we are bulky, it's okay. But how it will behave with multiple model analysis. What will be its harmonics? So how it will behave with respect to different level of structural deformations or your foundation variations, stiffness variations. So that is very, very important. Once you analyzed that, I should not waste material, so I have to go with the topology optimization, reducing the unnecessary material wherever it is not required. Otherwise, it's a national waste. So this way, this is very, very important. I don't know how we are doing it the first time. More and more, understanding the prototype, recording the data, and correlating the vibration related to which element. I did the prototype design, manufactured, qualified, assembled. Now, during the testing, how it behaves. At what frequency it takes the harmonics or higher amplitude with respect to its operating speed. It may be a gear miss frequency, it's the ball pass frequency of your bearing or shaft deflection. How we are able to correlate, correct it during the first proto. So we are doing all the checks in the design. Anyhow, there will be chances for minor error. That error to be corrected here. Otherwise, I will do third iteration, fourth iteration. It will continue, or otherwise, worst case, it will discontinue project. So that way, very, very important to analyze. Material. When we are selecting the material, we have the options today. Multiple heat treatments, case carburizing, nitriding, induction hardening. Even with case carburizing also, at what level of case hardness, whether 450 HV cutoff or 500 HV cutoff, nobody mentioning in the drawing when we are analyzing root cause. So the drawing is very, very important. What kind of heat treatment, what kind of case step, how to measure, how the transition support to be, how much retained austenite supposed to be allowed in the after heat treatment. Every information, if it is not provided in the drawing, you may expect surprises related to material also. And each material, if I am having a same center distance, here, this I want to explain little bit. This is SN curve. Generally, we'll call this as damage accumulation. You go through ISO 6336 part 6, you can get complete analysis on this. Means every material for its bending strength, that means this kind of attacking mode, how many cycles it will withstand, that is given by sigma F lim. So ISO 6336 part 5, the material standard gives all these things, ME, MQ, ML level. Please check, have we defined that? I am saying 18 CR material case carburized in drawing. Which level? It is ME level, MQ level. So what is its sigma F lim, H lim value? Who checks? I am damn sure 90% industry, there is a lapse. So how we will do the iteration? I am talking about one number, but we will have 20 MNCR5, we can have 18 CR, any combination. Which material better, which will have more load carrying capacity, that analysis to be put into AI mode so you can get solutions at the earliest. Otherwise, I will do 1 week, 10 days for this simple job manually. So these cycles say, for your kind information, any gear designed with respect to any software or ISO 6336 standard, the pitting is 50 million cycles. If this gear goes, so pitting should not happen, means no failure. It is, say, 1.0 safety factor as per the standard, means that torque it will transmit. When root strength point of view, if that material for a defined load passes 3 million cycles without any failure mode. It is having 1.4 root safety, or AGMA means 1.0 root safety. So this understanding is very, very much important when we are doing any new design. How I will choose a material, how I will get the material properties, not only yield stress, not only ultimate stress, also hardness, layer thickness. In addition to that, what is sigma F lim, what is sigma H lim? It's an engineering term. That value defines the right material. People will choose 1500 also, 1650 also, no mentioning in the drawing. Heat treatment. I said already, so case depth, where we are having the layer, how much case depth, it should not go to the tip portion, it will brittle and it will chip off. If it is goes extra at the root portion, it will break again. So the trade-off, and very, very important today, is 50% of final rejection happening due to the case depth or wrong heat treatment, due to case depth variation or crack or some kind of brittleness, anything related to case depth related to heat treatment. So this is very, very important. We have to put iterations on furnace performance, its consistency, its calibration. That's why NABL lab or NADCAP certification or whatever we are calling, they are insisting this kind of requirement. Coming to the materials with respect to foundry. So are we doing the first time right castings with the flow simulations? So today, for, in my opinion, 10 to 15,000 rupees, we can get a simulation also. So are we doing it, taking it first time right, no cold chills, no defects in the foundry? How many people we are doing? Just I'm saying, so many software available, so many service providers available in India. We can take any one of them help to get the best solutions. And coming to the next is particularly tribology related lubrication. So many mathematics coming into the CFD area. Earlier, it's very tough to do the CFD because of mesh creation, time consumption. Today, meshless approach came. That you see that smoothed particle hydrodynamics, SPH technology. I don't need mesh also. I think later we have luckily here IIT Madras team here. So they will also having some part from my client level. So they are also doing some kind of analysis. They will update you. But many softwares, Simulia, Flow3D, AVL, D-Drive, NextFlow, there's many softwares available. You can find out, they will do better simulation analysis. This churning is very, very important because the lubricant viscosity, then level of lubrication means quantity of lubrication. If it overflows, it will act as a pump. It will create a power loss. It will create a temperature rise. All negativity. Lower means by default scuffing will happen. My gear will fail. How to trade off between the right level of oil viscosity, quantity rate, considering my complete operation range. I can run with 300 RPM motor or 3000 RPM motor. How I can do that? So it need a lot of iterations. Certainly AI tools associated with this kind of software today helping us a lot. Tooling, very, very important because my favorite subject. So we are just giving tools. Sorry to say, 14 number of teeth means one cutter, 55 number of teeth means another cutter. There is some kind of strategy coming from industry. So how we will decide number of tools requirement, how much stock required, how it will do the undercuts. So this simulation also possible with the software, considering the heat treatment, how the trachoidal forms, how the root fillet comes. This is another different subject. Getting a single tool, economical for gear manufacturer. Providing the simulated reports from how people is my suggestion always to my clients. The reason is it will give you the confidence. Today, every people in the important industry, they are saying where your SAP starts, what is the form, can you provide this portion FEA analysis or do a test and provide me the root stresses achieved. Here very, very important to just define the hop parameters or shaping tool parameters, simulate with the software, how it will do the cutting, what will be the formed tools. So many softwares helps you, including GitSoft. Ultimately, I'm not a brand ambassador for Gleason, just I'm putting a representative image. Okay, so there are so many people also, everyone friends of mine also here. Okay, so the thing is, my representative is when spiral bevel comes into the picture for the applications, how we are doing the design rightly first time. Multiple, Klingenberg different technology, Gleason different technology, Curvex different technology, how the cone portion comes. Many drawings I had seen, they will put all the three triangles, angle will be there, how the cone point joins together. It's all joins together on a pitch point, or it goes with a tilting constant slat, variable slat, multiple technology. How a manufacturer will know from the designer, he doesn't know anything about the manufacturing methodology. This is the problem today. Wherever failure happens, or not matching with one component to another component, we can face this. Every machine manufacturer today concentrated to put the ground gears inspected by another machine. The correctors are again feedback to the grinding machine, no manual interruption. That means automated already. But how much we have to provide in the first time, right? Certainly AI kind of continuous multi-data analysis will help us. Otherwise, it is an iteration kind of stuff. Sorry, before that, I forget to the last picture. That's a Burghausen noise tester. How many people concentrating on grinding bones? Nitrile etching methodology or Burghausen noise methodology. So this makes a windmill gearboxes failed multiple times with my experience, coming within 3 years time, 2.5 years time, one kind of failure. Again, subsurface failures like TIFF, tooth, inner, flank fracture kind of stuffs. So many failure modes already available. Industry not following this as of now because wind, few aerospace or few marine gearboxes they are following. But other people not either are not unaware about this or not following. You can use extensively rapid prototype. This is my favorite. So whenever I'm doing any design with a conceptual model, I used to make a rapid prototype model, feel it first hand aesthetically. Then also it will help you understand what will go wrong with respect to assembly sequence and other thing. And pattern also today, I can say Magna at Coimbatore, they have even metal printing also today. Everything technology upgraded with respect to new things. No need to say AGMA having complete standards. You can go through there. Parallelly equivalent ISO standards with a different area. Just for your easy understanding, I have given here. You can take a snap if you like. So slowly in India, we are having a control body ministry putting QCOs, quality control orders. Already chain came. Bonfiglioli and other people now fight for gears, but luckily withdrawn. OTR is withdrawn. It may come any day. That time, every manufacturer will run or will rush with approval category if we are not giving our requirement rightly in these standards, not ISO, not here, because India represents BAS as a QCO approval authority. So many things, even including jet of Suzlon, last year due to import raw material issue, lost huge profit. So I request whomsoever related to gear or chain already there, anything related to power transmission, be part of any kind of certification body. Otherwise, we have to face a lot of issues later. And I'm suggesting any engineering design has to have the complete data with respect to manufacturing, accuracy, inspection, all the levels. What's the wrong? Provide every information, whatever methodology good for the manufacturer, let them take it. Many gears, we will put backlash as per manufacturing standard. How manufacturer knows your approach, whether it is a low backlash requirement, high backlash requirement, or what kind of tooth depth system required. So complete full information on accuracy, how to inspect, how to graph it. This all information is very essential in the drawing. Even if you are using a crowning kind of stuff, give in a graphical format in the drawing. That will help your manufacturer. Yes, my CMM P40 or J's or whatever methodology, accurate, anything, where to get, even if it is a variable helix crowning plus lead crowning, please provide in graph very, very clear way. Otherwise, people will confuse with respect to numbers. And very, very important for mass production people, these single flank, double flank testers as an approval item for your supplier. So we are putting into the machine goes some area, then they are returning back due to noise and other things. These single flank and double flank testers will help you just rotate one 360 revolution, find the errors as a cumulative F2 days level. If this is beyond your design level, please reject or do the corrective action. And no need to say, our gearboxes, wherever like windmill gearboxes, industry gearboxes, some area now came with intelligent control systems like SCADA, CMS and other things. Soon, it may be mandatory for every critical equipment. So, it's better to integrate all the technologies in the gear design itself and control our vibration levels in accordance with respect to any one standard. At least ISO means comply with ISO level. Now, another important today, not only required for complicated instruments, even with your cell phone, we can record the data, means sound intensity, just rotating the cell phone around the gearbox, get this data signal, analyze it for sound intensity. Even with that also, we correlated some 80 to 90% we could able to match. So this is another tool in advanced technology. And no need to say about full load test. Ultimately, this is one kind of Logia product what we are doing. The extruder gearbox, which is very, very critical for the complete, say 12 crore machinery unit for plastic packaging unit kind of stuff. The digital twin is very, very important. Logia invested as a special technology center at Bangalore. DIC they call Digital Innovation Center. Putting their complete analysis for the digital twins. Means how machine will perform. They will do iterations here and they will correlate parallelly. Any kind of correction required, they will do it in advance. So this kind of AI tools also supporting lot. Okay, now if I have 5 minutes time. Okay, I request one of my client come IIT Madras. There is an aerospace, Mr. Satya Chakravarti, is the professor come. He started his own startup company called E-Plane. They have an excellent product, just for your understanding. This will be the future, in my opinion, for Bangalore or any crowded city. It's like an air ambulance. So, I think 300 kg payload, they will give details, just I'm giving an intro, just for your benefit. 300 kg payload within a very confined space of this element. Direct driven gearboxes. They did complete research analysis because they have 20 kind of aerospace experts in their company plus 200 kind of employees inside. Done the analysis, complete gear design. Thanks for their offer to me also to be part of their design and development activity in the gearbox. Done the prototype, first time right, because we followed all the steps maximum. I can say not all, at least some 60 to 80% of these tools to get the first time right tool. They manufactured, assembled first time right, also tested. So they will give some brief on that. Please welcome Kamala Parvati and team.
So thank you for this opportunity. So good morning everyone. So I would like to introduce myself. Myself Kamala Parvati from UB Flight Technology Private Limited, located in IIT Madras. Along with me, this is Muthu Kumaran, he's my colleague. So what are we basically doing is, it is a compact eVTOL in urban air mobility. So what made us to do this is, like, as you know, like cities like Pune, Bangalore is cluttered with lot of traffics today. For a 3D realization of a sustainable solution, we have come up with an urban air mobility in 3 different forms, like air taxis, air cargo and air ambulance. So this is founded by our professor Satyanarayanan Chakravarti from Aerospace Department. So he's an entrepreneur in different deep tech startups like Agnikul and other companies. So our vision is to provide safe, sustainable, and efficient urban air mobility services at affordable pricing to intercity and intra-cities across all over India. So one of our key note is like we are the sole private entity in India to have design organization approval for aircraft design, so which is provided by DGCA. So what made us to build in-house powertrain transmission is like the motor in current market like BLDC and PMSM is capable of providing a high RPM and a low torque, which is different for our application. So this made us to realize to build an in-house gearbox and the respective motor and respective powertrains. So these are all the key challenges that we faced, what made us to build the in-house gearbox. These are all very different from automotive and helicopter gearboxes, like different operating RPM, different axial loads, and these are all listed here. So in continuation of it, these are all the aircraft requirement and the system level requirement, which made us to realize the gearbox component, which is matching the overall aircraft architectures. So these are all the twin challenges that we are facing, that is high speed and high torque, and these are all the engineering solution that we have realized with our manufacturing capability. So these are all the few clips of our manufactured gearbox, which is designed, manufactured and under endurance testing. So as we are in the verge of complete testing, we are planning to scale up our production from prototype to further market scalability. So we are open to collaboration in the different domains. So, and thank you for this opportunity. And handing over to Mr. Mahendran, sir.
For further information about this product or anything related, Mr. Aravind Subramaniam is a technical lead for this project at E-Plane IIT Madras. You can directly contact through this phone number or emails directly. Thanks for this opportunity. Okay, so coming to conclusion. So every industry need its own specific. So the design standard may be same, approach may be same, but how we are tackling the software, numbers, how we are doing the iterations, this matters very much. And with respect to this, why we are saying need for AI in mechanical engineering is we would like to say experience-based decisions. And say that will help lot. Meantime, data also very much important. So AI will help us lot. So how we will soon integrate every mechanical related problems to an AI base, like software people, how much. So there may be crores of people working for programming AI with other disciplines. So we also need to put our industry level integration of tools in the gear design. So my last word is R&D is no longer as a department. So it's an intelligence ecosystem of manufacturing quality and everything. So forum open for questions. Thank you very much.
It's an excellent presentation. Very innovative and then mind-boggling points over there. So I just wanted to draw your attention that when you talk about loaded tooth contact analysis, all the points have been systematically listed. I mean, somebody can follow this as a table and then go systematically how to analyze that. But one observation is in aerospace gears or anything, one point, like you said, ISO 6336, it is edition 4 in 2019. There's a seminar also in India for bringing the awareness to people to how to address that, bringing the bending fatigue strength. But the missing thing which came up later is the crack growth initiation in the substrate of a tooth. More importantly, in the fillet root and this. So the manufacturing processes for hobbing, grinding, all the things, they tend to create surface stresses, which have been seen by ZF also, many cases in automotive designs also. So there is a difference between the stress level accumulation in the root and in the flank. So these are not addressed in softwares yet. So this, when it goes to heat treatment, it opens up and tries to give FH alpha deviation if you systematically adhere to. And this is absolutely necessary in aerospace gears, especially in helicopter gear. I have experienced it. And then in that case, we must try to see how we can adapt it in the process control as a strategy. But integrating the crack initiation and at the stress, there is a work done by Dr. Witzig in Technical University of Munich in 2013 or 14, very mind-boggling thing, led by Carsten Stahl from the well-known name in gear engineering worldwide. And they have experience and putting known parameters like Young's modulus and fillet radius, effective radius of curvature, all these things put together known values into an analytical model and proved it also. And if you search in AI, it comes, but it keeps jumping, asking various, unless you are knowledgeable, they navigate you somewhere else. So those, if they find out the concentration of equivalent stress in the substrate, and ISO 6336 does not address that. So they say also. So you have to individually design for aerospace gears. NASA also recommends this, and you can go into the depth of how they go for including helicopters and all. So that becomes necessary to bring in to avoid surprise when it is in service. This is okay first time, but when it starts working, maybe 1,500 hours of flying, it may come up as a surprise. So we try to go into that. When high speed comes, the shift of the design changes to scuffing resistance. We used to call as initial scoring resistance in those days, which has become scuffing now. So that also has to be seen, and it is necessary to know the temperature of the tooth. So there is possibility today to know the tooth temperature when the pitch line velocity increases. 1 year ago, we tested it also in Mysore. We are able to capture that. And there is an analytical equation which was developed by ISO, which has still not been balloted. It was still in discussion in 2023. So John Amendola was heading that committee internationally. So they will come out with the more or less quadratic equation, bringing in Martinalia, Akazawa, and all those people, and integrating it with how to establish the tooth temperature. This is ANSI J14, I think. So this it can be seen by predicting, and then you can match how much you deviate with the loss of dissipation.
Thanks, sir. Thanks for your knowledge sharing. Notable to the team also, useful. Certainly, many these kind of research papers, they will particularly TIFF kind of stuff. ISO TC 63, when they are forming it, so many topics they are putting into a research level topics. Hope we will get that standard soon for our public use, or at least a technical specification. If not a standard, as a TS paper, if we get, we can use it for multi-area. Thanks for your knowledge sharing, sir.
Yeah, thank you. Thank you for the wonderful presentation. Sri Ram Krishna, Dive CAE. Very happy to see that you also mentioned us in one of your presentations. So we develop a mesh-free CFD software. My question to you would be is, in terms of adoption of a mesh-free technology in the industry today, I see a lot of challenges. They're also cloud-based, right? What is missing from our end for a mesh-free tool to be actually an industry standard going forward?
A little bit loud.
Yeah, sorry.
Thank you.
Yeah, the question was more on the lines of for adoption of mesh-free technology in the industry today, we see a lot of friction or challenges. What do you think is missing from incumbents like us in the mesh-free space to actually make mesh-free software an industry standard?
See, honestly saying, I am not a CFD expert, first of all. So I'm working with multiple partners or supply. Based on that, any kind of code, it based on some principles. Either Bernoulli's equation, take it from a very fundamental level, or advanced Navier-Stokes equation, whatever you are following, it based on some mathematical formulation. It to be correlated otherwise. Unless it is correlated and proven, mesh technology or meshless technology. So it will not provide the same result what we are expecting at the things. If the question is to the forum, somebody knows this, I'm honestly saying, to advise or to give you a right solution on CFD area, with my experience, either CFD with mesh technology or meshless technology, the correlation with respect to our practical hit, whatever we are experiencing with the gearbox, comparing to the software what provided by the third party as a service provider, it's matching 60% to 70% is today. Luckily, not 80%. What I'm expecting at least 80, 90 means if we go with ISO 6336, at least we'll get 80% to 90% correlation. So this CFD is evolving area. Certainly, which will better, I can't comment. Sorry for.
Nice. Thank you.
Okay, thank you very much. You can write questions. You can put questions to me at any time later also through my email ID. Thank you very much. Thanks for your presence.
Yes, I would like to thank Mr. Muthu for his time and also for getting the IIT team here. I think we've definitely had an innovative start to the day. Requesting Raghu to please join me on stage to present a memento. Raghu is the director of Virgo Communications and Exhibitions.
A special thank to Muthu. He always, is part of our knowledge sessions, and he's been guiding us ever since we started Gate Technology India and the IPTEX exhibition. Thank you, Muthu, for your contribution. I must appreciate you. Thank you very much.